Welcome to this live session Sunday at 1 p.m. going over word problems, basically applications of linear equations. Before I get started with sharing my screen, I do want to share that tomorrow is Labor Day, and so Grantham University is closed, so I will not be responding to any emails, phone calls, or anything tomorrow since it is my day off. So anything you email me once I'm off the computer today, we'll wait for Tuesday. All right, so let's get started. Okay, applications of linear equations. So this is basically word problems. This is where a lot of people struggle, and I'm going to try to give you some tips as best I can to help make the process a little easier. So first, what is mathematical modeling? Modeling is the word that we use when we talk about word problems. So mathematical modeling is the process of taking real-life situations and translating them into algebraic expressions or equations. So the modeling is the process of getting the equations that you then have to solve. This process relies on critical thinking, problem solving, your ability to translate words and phrases into what they mean mathematically, and then your understanding of mathematical concepts and how things work. I recommend that you click on this link to see a list of real-world uses for mathematical modeling so you have an idea. And actually, I'll just pull it up now to kind of show it to you, just so you have an idea of what modeling is used for in the real world. Okay, so it goes through why, mathematical modeling, a list of applications. So let's see, artificial intelligence, because we have computer programming students. Computer vision, image interpretation, robotics, speech recognition, optical character recognition, reasoning under uncertainty, biology, if anybody's going into anything that might need biology, protein folding, the Human Genome Project, population dynamics, morphogenesis, evolutionary pedigrees, spreading of infectious diseases, animal and plant breeding, computer science, image processing, realistic computer graphics, criminal justice stuff, fingerprint recognition, face recognition, electrical engineering, stability of electric circuits, microchip analysis, power supply network optimization. If you're going to anything finance, risk analysis, value estimation of options. For everybody, web search for internet, optimal routing. Let's see what else may be relevant. Pharmacology, docking of molecules, proteins, screening of new compounds, analysis of elections, formalizing diaries of therapy sessions. And then there's different types of modeling: numerical linear algebra, numerical analysis, data analysis, which is basically statistics, functional analysis, a whole bunch of stuff. And then, it goes into a lot more details about how to go through the modeling process. So I recommend taking a look at this. I think this would be very helpful and just gives you an idea of what kind of things are used, that we use mathematical modeling for. Okay, so some tips for successful modeling. I recommend that you keep a list handy of common words and phrases and what they translate to algebraically, basically how they translate into math. Keep a list handy of common formulas and equations. Once you do a lot of modeling problems, you'll see the same sort of format over and over again. So if you have those handy, like you recognize this is a mixture problem, this gets set up this way, this is consecutive integers, this gets set up this way. If you recognize those overall patterns, keeping that list handy can help. Drawing pictures. For the things that we are doing this week, drawing pictures are not as handy, but once you get into more like the college algebra stuff for next class, and you get into further math, drawing pictures can help a lot. Drawing pictures helps if you have anything that's geometry related. And I recommend that you start by writing down what you know and what you are looking for so that you have your end goal in sight. Okay, so there is a problem-solving procedure. Start by reading the problem, You want to do it carefully. So when I read the problem, that's usually when I am drawing pictures, making tables, kind of writing down the information, labeling it. It helps me process what I'm reading. So I don't just read it. I write down stuff as I read it to actually process the information. Then you want to assign a variable to represent what the unknown values are. So whatever you're looking for that you don't know, make sure you have variables representing those. Sometimes you need to have more than one unknown. Sometimes you don't need them all. Sometimes they give you extra information, but write down the things that you don't know that you may need to find. Once you've done that, the next step is to actually write down your equation, or sometimes you have to write down more than one equation. Sometimes it helps to reword what you wrote into something that translates better mathematically. This is probably the hardest part, is actually getting the equations, and that just comes from practice of seeing how different types are interpreted and really understanding, oh, this is what it's saying, or like understanding the underlying process and understanding how things work in the real world can help you translate it into math. Once you have your equation, or two equations, or three, or however, then you solve. Solve, find an answer for your variables. But you're not done there once you solve. You need to check your work to make sure it actually makes sense. So make sure it actually works in your equation and make sure that you haven't made a mistake solving. Ask yourself, does this answer make sense? Is it reasonable to have this as an answer to this problem? And make sure is the number that you just found, is this actually answering the original question? Because sometimes it doesn't, and you need to do some extra steps. Once you know that your number's right, it seems reasonable, it does answer the original question, you want to state the answer to the problem. And this is in a sentence, because you have word problems. And so you need to answer a word problem with words, basically, especially if it's real life. If it's a word problem that's not tied to a real life situation, you don't really need to have the sentences as much. But if it's tied to a real world situation, you need to have a sentence that puts the answer in context so that it shows somebody who's reading this what that answer means. Okay, so I have this linked in the supplemental materials, but I also have added it here, some common words and then what they translate into. And then I've listed which ones are translated in the opposite order that they are in English, which ones the order doesn't matter, that sort of thing. So I recommend keeping this handy, and I have examples here so you can see what they look like and how they translate. Okay, and so now on to the examples. So here I've got two separate examples here on this slide. In a math class, the number of students who received an A in the class was 5 more than the number of students who received a B. So I'm just going to work through the process as I would any other time that I'm solving this, so you can see how the process goes. I'm going to basically explain out loud what I'm doing. So I read the first sentence. Okay, the number who got an A, whoops, I thought I was on my pen and I wasn't. Okay, so the number who had an A is 5 more than B. So I'm basically taking that sentence and I'm just translating it, removing the extra words and just trying to keep it more condensed so it's a little easier to translate. Okay, if X represents the number of B students, so that means X is B. All right. Write an expression for the number of A students. Okay, so A is, now the word is usually translates to an equal sign. And then 5 more than, that is addition. We go here and get my more than, oops, I thought it was in the highlighter. I was accidentally in the pen. More than translates 8 more than X, 8 plus X. So going back to my pen, okay, so 5 more than would be 5 plus X. Now, the question says to have an expression. An expression means no equal sign. So what it's asking for is the right side, not the part with a equals, but the rest of it. So your answer is 5 plus x. So it's key. It says expression, so that means no equal sign, so just the part that involves x. Okay, so now the second example here that I have on this slide. Rebecca downloaded twice as many songs as Nigel. So I'm going to just use R for Rebecca. Had twice Nigel. So twice is multiplication, twice as many. So I just translate R had 2 times Nigel. Okay, so if X represents the number of songs downloaded by Nigel, so okay, that's X. And then now that means I have 2 times X. Write an expression for the number downloaded by Rebecca. So Rebecca, and the word has, that is an equal sign. Just like the word is. Those are equal signs. Basically, if you have a verb, so this is how you can connect your language part of your brain to the math brain. Verbs like is, had, has, was, those kind of things, those generally translate into equal signs. So that's how I knew R equals 2 times X. Now once again, it says to write an expression. So that means I just want the side that includes X because it's saying what X represents. So if X represents this, write an expression. So I just want the part with X. So that means the answer is 2X. Fairly simple. The hardest part is just, getting used to working those things out. And I find trying to rewrite it in a way that understands to me in simple language, skipping most of the extra words, gives you an easy way to translate it. Okay, so previously, these are ones we can't solve because we're just writing expressions. Now we're moving on to things that we can solve because they want us to actually find things. So these are ones that are not necessarily related to real-world situations, so you don't have to give your answer as a sentence because they're not really connected to a real situation. So the first one here, 15 less than a number is 41. Find the number. Okay, so first look for that verb. I said that the verb is an equal sign. So the verb is generally the word is. So I'm going to put equal, and then right after that I have equal 41. So I've got one side of my equation already. Next we have 15 less than a number. So if I have an equal sign, then that less than is not the less than symbol. That less than means subtraction because I already have a symbol, it's the equal sign. So less than a number. So I'm going to go back to my translating. Less than, 7 less than t, that one gets translated in the opposite order. So you're subtracting the first thing. The way that I usually do this so I don't have to worry about the opposite order is that instead, less than, I put my subtraction sign, and then I just kind of put arrows there. So less than a number. So that's 15 on one side. And then it doesn't give you a letter, so you can use any letter you want, and I will use N for number. Now the alternate way is to put the 15 or the negative sign with the 15 because of the less than, and then put a plus sign. Because subtracting the same as adding a negative, I could write this as negative 15 plus N equals 41. If you don't want to try to worry about reversing order, say less than and put the negative in front versus where the words are placed. So it's up to you on what makes sense to you. Okay, so I've just translated this. I just took the words, took a look at what they mean, and then wrote it down. And now it says find the number. So now you're solving. So we're going to add 15 to both sides. So 41 plus 15 is 56. So I have n, and my pen doesn't want to write well. N is 56. So we have found the number. So let's double check. Did you get what it asked? It said find the number, number equals 56. We are done. So because it's not really tied to a real world situation, that is completely fine, and leave your answer like that. Okay, so now the second example here. This one's a little lengthier. The difference of 14 I'm trying to do too much at once here. I'm going to just read the whole thing first. The difference of 14 and 3 times a number is the same as the sum of the number in -10. Okay, first look for that is. So I'm going to move to the highlighter, look for the verb. I want to make that green because I want to keep all of my verbs as green. So that's where your equal sign. So that means everything to the left of that, left of the green, that first part is on the left side of your equation. All the words that follow are on the right side of your equation. So you have a sentence that's now divided into 2 parts because of where the verb is. So that is where I'm going to put my equal sign. So now I'm going to do the left side and then the right side. So I've got the difference of 14 and 3 times a number. When you see the word difference, that means subtraction. And the subtraction symbol then goes where the word and is. So I'm going to have my minus where the and is, which means then I have 14 minus, and then 3 times this number. This is literally the times symbol, so that's 3 times, and then let's say the number is n. So for my left side is 14 minus 3n, and then I have my equal sign. Now the right side, after the verb, I've now got the right side of the equation. The same as the sum, and sum means addition, and that sum goes where the and word is. It'd be better if I could have fit these all in one line so you could see that. So I'm going to have a plus sign, and the left of the plus sign I have the number, so that's n, and then -10. So that gives me, on the right side of my equation, n plus -10. So words like difference and sum, you put the symbol where the word and is. And then either side of that and, you have the actual parts, basically. So let's see if I go to the highlighter. So I've got my ands, and then let's choose different colors, just say blue. 14, 3 times the number. So 14 minus 3 times the number. And then the number and -10, n plus -10. So that and is where the symbol goes. And then on either side is what's on either side of that symbol. So now that I've translated this, now I need to actually solve in order to find the number like it tells me to. So I like to have my variables on the left, so I'm going to subtract n from both sides. So I got 14 minus 4n equals -10. Now I'm going to subtract 14 from both sides. And then I'm going, because I don't have a lot of space here, and move kind of up to the right here. So that gives me -4n equals -24. Now I divide everything by -4. We get n equals 6. So the number is 6. Now you should be checking your answers for all of these, but I know that these are the right answers, so I generally don't do that when I'm teaching it because I know that these have been done correctly unless I did some weird thing with my math. But you should be then checking your answer, and you can even check it like back in the sentence. Say the difference of 14 and 3 times a number. Okay, so 3 times 6 is 18. The difference between 14 and 18 You know, you can kind of work it out that way as well. Okay, now this example, this slide is all about consecutive integers, which are a special type of word problem. These usually don't show up too much in real life, but they do show up just as a good exercise in problem solving. That's why you'll see them even if you may not encounter this in real life. It's a good way to get you thinking. So there are some things with consecutive integers. So consecutive means one after another. So if one of the numbers is n, the next one is n plus 1 because it's one more. You're adding one each time. Then the next one, if I add one again, is now n plus 2 because 1 plus 1 is 2. So if they're consecutive, you have n, n plus 1, n plus 2, n plus 3. You're adding one each time. If they're consecutive even or odd integers skip every other one. So if the first even or odd is n, then you have to add 2 to get to the next one. So those, even and odd, it's every other one. So you're skipping every 2 to have consecutive even or consecutive odd integers. So that's the important part in order to solve these type of problems. So first one, the sum of two consecutive integers is negative 67. So I've got that is negative 67 gives me equal negative 67. I have the word sum, but there's no and here because they're indicating it with two consecutive integers. So we always start with n. So I have n plus, because sum is addition, and then the next one is n plus 1. So you'll look in my blue, consecutive integers, n, n plus 1, n plus 2. So if there's 2 of them, you have n and n plus 1. If there's 3 of them, it's n plus 1 plus n plus 2, and so on. So now I have an equation that I can solve. So n plus n is 2n. So I have 2n plus 1 equals negative 67. So I subtract 1 from both sides. 2n equals negative 68. And then I'm going to divide both sides by 2. I'm running out of room here. That gives me n equals negative 34. So it says find the integers. It's plural, so you need to find both of them. And that word integer is key because integer means that it's positive or negative and it's a whole number. So if you solved and got a decimal or a fraction, that means you made a mistake somewhere. The mistake is either in your solving or if it's in your setup. But I've got a negative, I've got an integer here because it's a whole number and it's either positive or negative. So that part's okay. And it says find the integers, so I need to find both of the consecutive numbers. So if n is negative 34, then the next one is negative 33 because you're adding 1 to it. So both, you need to find both numbers. And that's where it's important to go back and see, are you answering the question? Just finding n doesn't answer the question because the question wants both of them. So you have to go back and double check. Okay, now the next one, we have the sum of two consecutive odd integers. So I've got my is 52, so that's equals 52. And now consecutive odd. So the odd or the even means you skip, you do every other one. So that's going to be the highlighted parts. So that means n plus 2 equals 52. So I add like terms on the left, n plus n is 2n. So I have 2n plus 2 equals 52. So I subtract 2 from both sides. I got 2n equals 50. And then I divide both sides by 2. Once again, I'm sort of running out of room. N equals 25. So it says find the integers. So first, whole number, I'm okay. Now it says 2 consecutive odd, so I need to make sure that my answer is an odd number, because if it said 2 consecutive odd and I got an even answer, that means I made a mistake. But 25 is an odd number, so we're okay. Now the next odd number would be 27. So my 2 integers are 25 and 27. Okay, so now this is the last example I have, and this is a real world type of situation. So this is one where you'd have to make sure you answer it in a sentence. Maria has 15 fewer apps on her phone than Orlando. Okay, Maria has 15 less than Orlando, which I'll just call them or, because I don't want to put it O and then make it look like a 0. So the word fewer to me is not one that's usually, I think of that as less than, it's smaller. So I just translated fewer to less than. Now I'm going to translate that into our equation. So M, the word has is our verb, so equals 15 less than. So that was another one where the less than part means we translate it in the opposite order. So I'm going to just say Orlando minus 15. So I've got that translated. Now I've got if the total number of apps on both phones is 29. So total is 29. So total means you're adding everything together. So that would be Maria plus Orlando. Word is equals, and then 29. Okay, and now it says how many apps are on each phone. So that's what we're trying to find. Okay, so now I don't want to use, well, first let's just take a look at what's going on here. I'm going to switch to green. I have Maria plus Orlando is 29, but I know that Maria is Orlando minus 15. So instead of having something with 2 variables, I can replace my M with Orlando minus 15. So I could write Orlando minus 15, and then plus Orlando equals 29. So I'm basically saying, well, I knew that M is Orlando minus 15, and I have M, so I can replace that with what it's equal to. And then that way I have only one variable. I don't have M, I don't have OR, I have just the OR. And I don't want to solve with OR, so I'm going to just switch those as X's. So I'm going to rewrite this as X minus 15 plus X equals 29. So that way I don't have to worry about any weird variables. Okay. Now I'm going to add like terms and go ahead and solve for X. So X plus X is 2X, so I have 2X minus 15 equals 29. So I add 15 to both sides. And I get 2X equals 44. And then I divide both sides by 2. X is equal to 22. So I then, okay, so you solve, but you're not done, because you have to say, are you actually answering the question? The question says, how many apps are on both phones? So, okay, I'm looking for applications on both phones. So I need to know how many Maria has and how many Orlando has. I have to make sure I got whole numbers, because you can't have fraction apps. So I got a whole number, so that makes sense. Okay, and then I got to figure out what was X. X was Orlando. So to answer this, you want to put this in a sentence. So Orlando has 20 apps, and Maria has, so she has 15 less than Orlando, so it's Orlando minus 15. So I need to do 22 minus 15, which gives me 7. So Maria has 7 apps. And so I can even show the work there. If I got M equals Orlando minus 15, that is 22 minus 15. So now I've answered the question, and you've answered a question that makes sense, because if somebody was asking you to solve this problem, you just say X equals 22, I would be looking at this being, well, what's X? Is X Maria? Is X Orlando? Do you know what X is? What does that mean? And it's only one answer when I'm looking for two answers. So you want to be as explicit as possible to tell us, okay, Orlando has 22 apps, Maria has 7 apps. You've made it clear which answer goes with each person. You've made it clear that you know that you solved for the number of applications. It shows you know what's going on, you understood the problem, you've answered the question. So if you have any questions on this, you can send me an email, you can give me a phone call, you can give me a chat message. Hopefully this has given you some information and some understanding of how the word problem process works. You're not going to be an expert just from this one. I was not an expert until I've had lots of practice, and that's true for everybody because the way the brain is set up, words and math don't meld together very nicely. So the best way is just through lots of practice, recognizing patterns, seeing different types of problems. So don't feel like you need to be an expert right now. You're not going to be, as long as you're practicing the process. All right, I'm looking forward to seeing you guys on our next session. Let me know if you have any questions.